Hey everyone, welcome to Cassandra Lunch number 99. We are almost at the big 100. If you have any topics or suggestions that we should do for the big 100, definitely let us know. Drop a comment or drop something in the real-time chat as well. And we'll take a look for next week. Today's talk is going to be on CQL Arithmetic Operators. I'll be the speaker for today, and I'm an engineer here at Anant, but I'm also a co-organizer for this event, as well as Rahul Singh. We are looking for guest speakers, either here at Cassandra Lunch or our sister lunch, Data Engineers Lunch. If you are interested, feel free to reach out to me. My email is listed below, as well as if you're interested in sponsoring Data Engineers Lunch or Cassandra Lunch, also you can feel free to reach out to me. We are a part of Data Community DC. Data Community DC believes in building an inclusive environment. So no matter your race, gender, sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, falls under Data Wranglers DC. So there's a ton of organizations, a ton of events. If you're interested in a specific organization or a specific event, you can find out more at datacommunitydc.org. So what do we cover here in Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra in the ecosystem. So whether that be open source Cassandra, like we'll be doing today, enterprise Cassandra, like DataStax, compliant, variants, Scala, Yugabyte, Keyspaces, Cosmos DB, as well as tools in the ecosystem like Airflow, Spark, Kafka. So anything that is, talks, or plays well with Cassandra, we cover here at Cassandra Lunch. If anyone's new, say hi, hello. If you're watching on YouTube, don't forget to like and subscribe so you can keep up to date with all the future Cassandra lunches, as well as future Data Engineers lunches, as well as watch past ones. Group roles, if you have a question, please ask it. Be polite and courteous to others. This is meant to be a community, so please do share what you know with us. If you have any experience about any of the topics that are being talked about, or if you want to learn more about it, feel free to ask questions. The more you know, the more everyone will know as well. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We also have some institutional organizational sponsors. If anyone is looking for a job or has any jobs to offer, feel free to drop links to job boards, resumes, etc., and we'll get them transferred to and from, as well as if anyone has any meetups, hackathons, or conferences or classes that they would like to promote, feel free to drop links to those as well. DataStax Astra currently has their build-a-thon ongoing. The third month has started, so it might be a little too late to join, but if you can crank something out, you can try. But if you qualify for one of the top 3 winners, for the round of May, you can qualify for the demo day as well, which will be on the 28th of May. And there are cash and swag prizes to be won for each round, as well as demo day winners as well. Anant is hiring for full-time or part-time positions, data platform operators, engineers, or architects. You can find out more at careers.anant.us. We also have some upcoming events. Again, our sister lunch, Data Engineers Lunch, happens every Monday at 12 p.m. Eastern. Again, we are looking at a more variable time slot to cater to a live worldwide audience, but all of these videos are live streamed directly to YouTube. So even if you do miss the video live, you can watch it immediately. And so don't forget to like and subscribe so you can keep up to date with everything, as well as the notifications so you can get notified when we do go live. And again, Cassandra Lunch 100 is upcoming. The topic isn't solidified for that yet, but we will update it as we get it. Cassandra Lunch, all these videos, again, as mentioned, are on our YouTube channel, youtube.com/notcorp. And we also have a playlist for Cassandra Lunch as well as Data Engineers Lunch. So you can find every Cassandra Lunch up until Cassandra Lunch 10 is when we started recording and putting them out there. So from 10 to 99 today, all of them are available on our YouTube channel. Cassandra.Link should be your #1 resource for all things Cassandra. If you have any questions or want to find good resources on Cassandra or anything in the context of Cassandra, you can find it at Cassandra.Link. And all of these resources are hand curated by the team here at Anant. And one more thing, Anant has released our second public runbook. This second runbook focuses on 3 common Cassandra data operations. I'll drop the link below so that way you can get the runbook for free and up your Cassandra game. All right, with that, let me go ahead and copy this link real quick. Paste it in the YouTube chat, and then also paste it in the Zoom chat. There we go. And let me know if you guys can see the new slide deck.
Yep.
Okay, great. So as mentioned previously, I'll be the speaker for today. Today's topic is going to be on CQL arithmetic operators. So with the release of Cassandra 4.0 a couple months ago, CQL arithmetic operators are now supported, and we'll talk about what things you can do, some of the things to look out for when you're using these kinds of transformations in your queries. But if you have any questions or comments, feel free to drop them in the chat or speak up. I don't necessarily have a preference. I am monitoring YouTube at the same time, so I'll be able to see it, but there is a slight delay. But yeah, if you have any questions, feel free to speak up. Okay, so the arithmetic operators in Cassandra 4.0. So Cassandra now supports 5 arithmetic operators: addition, subtraction, multiplication, division, and division remainder. So quotient, whichever you prefer to say. And these operators can be used in the select statements, insert statements, update statements, and delete statements. So that way you can perform some kind of computations as well as up your query game. So if you want, I thought it was really interesting that you'd be able to use the arithmetic operators in the delete queries. In the demo that we have today, we're mainly using selects. And so doing it with the deletes would be pretty interesting to see what the use case would be in using the arithmetic operators in a delete statement, as well as the arithmetic operators, because they're supported in Cassandra 4.0. They are also supported in DataStax Astra if you use DataStax Astra. So one of the important things to take into account when using these operators is that the return type depends on what you're using with the operators, right? So they have this table on the documentation where it's like, for example, if you're using a float and they're using a big INT, your return operator will be a double. So we'll take a look at that, an example of that in the demo, as well as type inference. So Cassandra will try to infer the type of literals that you're using to determine how the operation will be performed. If like the literal is an integer, it'll look at it and consider it an INT, big INT, or var INT. So if you have certain types of literals, it would categorize them in this section, right? So INT, big INT, var INT. So your return type might differ depending on what Cassandra is picking up. However, there are ways to control what Cassandra will see as the literal type. And so coming back to the inference aspects, for floats, Cassandra will see them as either doubles or decimals. And again, in some cases, Cassandra knows the return type of the expression and then can use it to infer the type of the literals as well. So this is where it comes in of where you can kind of override or help Cassandra out when doing your operations, which we'll be using today in the demo. So type hint is a way to, again, explicitly tell Cassandra what the type will be. So the example of a type hint would be to use, like in the example here, it's progress, multiply, decimal. So we're hinting the type, right? By 100. So your return type, you're hinting your control type, plus you're controlling what the return type would be according to the table of types as well. And then what we'll be using specifically in the demo is casting. So casting is another way to help explicitly tell Cassandra what you want to use, instead of it saying, okay, I see it as an int, so I can either use int, big int, big INT, or var INT. I'm specifically going to say, use it as a decimal, or use it as an INT, or use it as, or cast it as a INT or big INT, etc. So examples would be, again, you would just wrap whatever key you're using. So here in this example, it's progress, and you're casting it as a decimal ahead of time instead of using a type hint. So those are a couple ways where you can manually tell Cassandra what the type of parameters and kind of gather what you want to do for the return type as well. So precedence, it's in the, when it comes to math, right, you have PEMDAS, right? So operator preference or precedence follows that as well. So multiplication, division, and quotients operators have higher precedence than addition and subtraction. Again, if two of the operators are at the same level, they would be evaluated left to right. So again, PEMDAS as well. And then parentheses, again, the P at the beginning, parentheses will take precedence over everything. So everything would be done within the parentheses before it moves on to the next section. And then one of the cool things that I noticed while reading the documentation is that operations on timestamps and dates are also supported, which is really interesting because this way you can add and subtract durations from timestamps and dates in your queries. So for example, you can say, like in this specific example here, it says and day current date minus 1 day. So it takes current date, subtracts a day from it. So it would be yesterday, right? But you can get much more granular with that as well. You can do years, months, weeks, days, hours, minutes, seconds, milliseconds, microseconds, and nanoseconds. So especially this, I think, would be super helpful when you're using time series data. But I think another tool that could also be helpful in doing analysis or doing these kinds of queries in time series data would be potentially the Grafana connector that Obi had talked about a couple weeks ago. So that would be a cool way to visualize your time series data. You can find that video on our YouTube channel. I think it was Cassandra Lunch 2 or 3 ago, but you can find it in the playlist or just on our main channel as well. One thing to note is that because of the way Cassandra is built, UTC doesn't change with the change of seasons. So timestamps and dates are generally safe and should return the expected results. However, when it comes to like leap years and leap seconds, etc., the Java libraries used by Cassandra internally ignore leap seconds. So that's something you might need to consider when you're running very granular queries, potentially like at the second level, but it probably won't matter as much at a higher level. And with that, we will come to the demo portion. So today's demo, I have a GitHub repo. We're going to spin up Cassandra on Docker, and then we're going to run through just commands using CQL to show you examples of addition, subtraction, division, multiplication. And then also one thing I wanted to play around with, and it turns out it works as well, is arithmetic operators in addition to aggregate functions. So I'm able to use arithmetic operators on top of like something like sum, right? So if you have a use case for doing these kinds of queries, that could be something that's useful for you. But again, depends on your data model, etc. But today's demo is going to be done. But before I forget, let me copy this, paste it into the YouTube chat. This repo is also linked in the YouTube description, so you can click it right there. It's under accompanying GitHub. You can click it and open it there. But essentially what we're going to do here is we are going to run this demo entirely on Gitpod. So the thing about Gitpod, everything is browser-based. You can run Docker on top of it. So it's really useful to use for demos like this. So for me, if you don't have the Gitpod installation or the plugin on your link to your GitHub account, you can use the little button here. So I'm just going to go ahead and press this here. But again, as mentioned on the README, you can follow along as long as you run 1.1.1, the Docker command that starts Cassandra on your local Docker. But just to do a quick check, can anyone, does everyone see the Gitpod instance?
Yep.
Look, okay, great. So before I move on here, I want to open up the floor to any questions. Okay, doesn't look like there's any questions. So what we're going to be doing today, again, as mentioned previously, we're going to start up Docker or Cassandra on Docker. So it spins up pretty fast, but I'm just going to expand the terminal so that way it takes the entirety of the screen, and I'm going to zoom in a bit in case it's small for some people. Where is the view? Oh, view, appearance. I think I can just use Command plus. Okay, that works fine. Let me zoom out one. That may have been too much. Okay, so what we're going to do here is, where is my terminal? Okay. So just following along, we're just going to follow along the README. So the first step we are going to do is run our Cassandra instance. We are going to run latest, which will be 4.0. I forget the minor patch, but it'll be the major version is 4.0. And when you're doing this, don't forget to hit make public here. Just in case there are some connection issues, you can just press make public, and then you can see the port here in the port section of Gitpod. So let's go ahead and move this out of the way, and let's do a Docker copy command. We'll need to move our CQL file onto our container. So what we're going to do here is copy our stats.cql file and move it onto our Cassandra container, which is called Cassandra. And then we are going to docker exec it bash, or Cassandra bash, apologies. And then we are going to ls and then cat stats.cql. And I'll just talk about what's going on in the CQL file real quick. So in the CQL file, I have some data related to baseball. So if you're not a baseball fan, I am. I'm a pretty big baseball fan. Grew up playing it essentially my whole life through school as well. And so with baseball, like basketball, like football, numbers and metrics are very important, at least in the modern era. And so there's this whole thing called sabermetrics with baseball specifically. So if you're interested in that, there's a link to it on the README. But essentially what we're going to do is we're going to show you how you can use the arithmetic operators to generate certain kinds of numbers that are typically seen on baseball analytics, right? So we see here, if you're not familiar with stuff, I'll just walk through it, right? So we have home runs, at-bats, slugging percentage, hit by pitch, RBIs, averages, strikeouts, games, hits, on-base percentage, walks, sacrifices, intentional walks, total plate appearances, and runs. It's okay if you're not familiar with any of these terms. I'll explain it once we're in the actual part of it. But there's so many stats, but I cleaned it up so it's just smaller ones. And then also some of the other stats we have. So that was the offensive side. So, right, if you're a batter, those are typically the stats you'll see. And then there's also pitching stats. Again, there's a lot more stats we have, but I have removed a ton of them, right? So for pitching, we're specifically going to look at earned runs, innings pitched, games, and ERA. And we'll talk about those when we get to those portions of the demo. But what we're going to do here is we gave it a couple seconds. So if we docker exec it Cassandra CQLSH, we should now be able to get into our CQLH terminal. And we can see here we're running Cassandra 4.0.3. So we're running Cassandra 4.0. So arithmetic operators are supported. So what we're going to do here is just we're going to clear this, make some space. So the first thing we're going to do here is we are going to calculate OPS. OPS, and I'll talk through it right here, stands for on base plus slugging. So it's a metric that helps define somewhat productivity, somewhat power, et cetera. I won't go into it, but you can read more about it if you're interested. But essentially the way to calculate OPS is you add together slugging and on base percentage, right? So what we're going to do here is we're going to select the season, the slugging, the on base percentage, and then we are going to display a fourth column called OPS, which will be the addition of slugging and on-base percentage from just the data I'm using is like Derek Jeter World Series stats from 96, 98 through 2001, and then 2003 and 2009. So a couple years. But that's neither here nor there. But we have a couple rows. So one thing to note is, oh, I know why, because I forgot a step. Apologies. I forgot to import the file, which we are going to run docker exec it cqlsh flagf stats.cql. We need to copy the file onto the container so then we can then run the cqlsh flag C. So we are going to go back into cqlsh. Oh, nope. Okay. So, oh, nope. What's happening? Okay. Can you guys still see my screen? I accidentally pressed new share.
Yes.
Yes. Yes, I can still see. You might zoom in one click.
One click. How's that?
Better,
Good.
thank you.
Okay. So here what I'm going to do is, again, coming back to, we're calculating on base plus slugging. Just a very simple calculation. One thing to note, what we're going to do here, I'll come back to this, is I'm going to describe demo. So we're going to take a look at the schemas that we have. So we have the season as the primary key. It's going to be an int. We could have done dates if we had a lot more data and we configured it a certain way, but I just wanted to make it simple and clean. So it's just a 4-year, like year date. And so I set that as int over date. So we won't be doing any date queries specifically for this demo, but that's something you can do if you have date or time types. And then we have ERA as int because earned runs for the pitching data. Earned runs is generally a whole number, which is int. ERA is typically a float, decimal, double, whatever you prefer, but it's a 3-digit, 3 significant figures generally. Games generally single or int, and then innings pitched. Thing about innings pitched, it depends on where you're getting your data from or who's putting the data out there. So if you ever see like 6.1 or 6.2, the 0.1 and the 0.2 essentially means how many innings out of 3. So it's not actually a third. So 6.1 is equivalent to 6.333. 6.2 is equivalent to 0.66667, right? So it's 0.1 means 1 inning, 0.2 means 2 innings. So it's just something to keep in mind. So the math might not be super accurate, but it's in the ballpark, right? So, and then coming up to batting, similar things. For the numbers that have like 3 significant figures after decimals, it'll have a decimal type. Otherwise, most of the rest of the stuff is INTs. So going back to our thing here, so we can see our seasons are INT, right? Slugging is decimal, OPB is decimal. And notice we didn't have to do any hinting or casting of our decimal types, right? Because if we go back to our table here, and we look here, if we use a decimal and a decimal, our return type will be a decimal. So we don't have to cast anything on that to make it fit a certain way we want it to. So if we look at here, so 412 plus 389 is what? 11, carry the 1, 0, carry the 1, 801, right? So the math adds up. So that's just an easy, simple calculation between 2 columns, right? So the next thing here is we are going to look at subtraction. So when it comes to subtraction, or at least in the arithmetic operators, we can also chain multiple, right? So this is just a straight 1 minus 1 minus 1 minus 1 minus 1, right? Or minus x, minus x, minus x, right? We could put this in parentheses just to, if we have additional operators and we want to segment this specific data, but this is the only calculation what we're doing. So in this one, what we're doing is we're returning season, at bats, and then total plate appearances. Those are different, and I'll explain it in a second. But what we're going to do is we're going to say total plate appearances minus walks, intentional walks, sacrifices, and hit by pitches. And we're going to return that as calculated at bats. So total plate appearances are different from at bats. And so that's essentially it, right? So anything that is a walk, hit by pitch, or sacrifice are not counted as a at bat. So what we're going to do is say, okay, we have this many total plate appearances, and we take out all of the things that are not considered at bats. Our numbers should match, right? So if we run this, we see here our at bats for the year 1997 World Series was 17 at bats in the World Series, or 1999, sorry, 17 at bats. And then the calculated at bats, again, total plate appearances minus anything that doesn't count towards an at bat, right? So we're able to calculate things and then also subtract multiple times within the same arithmetic operation. So subtraction's easy, addition's easy. Now comes in a little bit more complicated stuff, right? So here what we're doing, let me close this out. Oh, terminals, split terminal. I want to close out of this one, and then I want to, there we go. Okay. Now what we're going to do here is we're going to bring in parentheses, division, and we're going to also add in addition, right? So what we're doing in this calculation is we're going to calculate on base percentage. So on base percentage is hits, walks, and when I say walks, I'm including intentional walks, which is IBB. So it's hits, walks, and hit by pitch divided by at bats, walks, hit by pitch, and sac flies, right? So that is two addition operations then divided between them two, right? So it's essentially a ratio. So it's this parenthesis operation, then it would do the division, right? So following PEMDAS. And so what we're going to do here is we're selecting it for a very specific season. Hey, wait, these numbers don't make sense. The math, like the equation, it looks right? Okay, so again, remember, these values here and these values here are all INT types defined in the schema. What we're trying to return is a decimal type, right? So if we come here, we see INT, and we do INT. So the return type according to the table is going to be an INT. So it's not going to show us the decimal values that we're looking for. So the precision that we need needs to be done via casting or hinting, right? So what we're going to do here is it's going to make it look a little fat, but essentially we're just going to cast each one of these into a float, right? Because if you remember here, for floats, Cassandra will consider them either doubles or decimals. So that will take care of what we need, right? According to the chart, if we're using a double or a decimal, and if we mix it with the double, so a double is not what we need, but a decimal is what we need, right? At the very least. And so coming in here, if we now paste in the casted types, so what we're doing is just wrapping each one of these columns in a cast, and we're casting them as float. And again, we're still pulling from the same specific season. We now get a calculated on base percentage that matches what was generated by whoever did the stats in the beginning, right? So again, that's just something to take into account when you're doing arithmetic operations with Cassandra is be cognizant of what your parameters are, param types are, be cognizant of what your return values you're trying to generate. Okay, so now we are going to do a multiplication operator. And this is where we're going to pull in data from the pitching data. So again, earned runs is a INT type. We're going to divide it by an INT type. So our return type should be INT. But again, remember, it may or may not infer properly. So what we're going to do here is we're also, when I come back to this, we are also going to specifically pull from the three-peat years, right? 98 to 2000, or is when the Yankees last three-peated. But essentially what's going to happen here is it does return an INT type, but that's okay. When it comes to closers like Mariano Rivera, his numbers are either 0 or 1 or 2. He's the greatest closer in baseball history, right? So it's something we can deal with. But if we wanted more precision, all we needed to do is cast the earned runs, an IP, in a float, right? So if we just do this manually, or it may prefer a decimal, but we can try it, right? So we're going to cast as, we are going to cast as float, and then we are going to cast IP as float. Yeah, so let me try decimal real quick. Decimal might be a little bit better for this specific example. Nope. So I'm having trouble, so I have to retake a look back at my chart to see what my types are. But again, the point is, if you want more granularity and more precision with what your return types are, just be sure to cast or hint, so that way Cassandra doesn't infer correctly for you. Okay, so the last thing we're going to cover for this demo is the arithmetic operators plus aggregate functions, right? So this may look a little chunky, but we'll talk through it, right? So what we're going to do here, starting from the end, is we're going to pull from the offensive stats, and then we're going to get the sum of at-bats. So we're going to get a total of at-bats and we're going to return that as total at-bats. We're going to get the sum of runs, so total runs. We're going to get the sum of ribbies, so total ribbies. And then we're going to get the sum of strikeouts. So this is going to be over, I think, 7 years of data. It's going to sum all of the at-bats, sum all of the runs, sum all of the RBIs, and sum all of the strikeouts. And then what we're going to do here is we're going to generate a couple of ratios, right? We're going to generate a ratio of like at-bats to RBI ratio, right? So how many at-bats does it take to produce an RBI? Again, this sample size is very small. This is seven series of at least 4 games. So the sample size relatively at minimum is 28 games, right? And then we're also going to get the we're also going to get the at bat to strikeout ratio. So this one's kind of up in the air, right? So we remember we had total plate appearances and we had at bats, right? So total plate appearances is just everything. So every time you complete a turn in the batter's box is a total plate appearance, no matter the outcome, right? So an at bat is anything except a walk or hit by pitch or a sack, right? So we're going to generate a value that is in every quote unquote ball is in play at bat, whether that be a strikeout, ground out, etc. I'm just going to consider it, throw it out there. We could swap out at bats for TPAs, but pick your poison, right? And then we're going to generate the strikeout ratio, right? And so doing so, what we're going to do here is we have, again, total at bats. So in 7 series, minimum 4 games, so 7 series, 7 years. So Derek Jeter went to bat 156 times, right? He scored a total of 32 times. He had a total of nine RBIs. And again, this is strictly the World Series, not including the ALDS and ALCS. And then total strikeouts. And then again, a generated at bat to RBI ratio. So in about 1% or 5% of the time he hit an RBI of all of his World Series, right? Just based on this, right? So 9 divided by 156, right? But his strikeout to out bat ratio. So if he didn't get walked or hit by a pitch, he was going to strike out 1/4 of the time, right? So that's like, it's baseball is a numbers game, but again, there's so many metrics that go into everything in terms of sports. But one thing to take into account is sometimes it's really an eye test. So take what you get with metrics, but or at least in the vein of baseball, sometimes you just can't beat the eye test. But who knows? It's it's still out there if sabermetrics is the one and true rule, but sometimes it's a combination of these metrics plus the eye test. If you're saying, hey, this person hits really well in this quadrant of the box, of the hitter's box, strike zone, right? But you've been beating on him all night and he can't hit that pitch, right? So metrics say don't throw it there, but in the game, you've been on him all day, right? So it's stuff like that. Just want to throw it out there. But doing these kinds of aggregations and arithmetic operators, it's really easy to show with something like baseball data or NBA data. I ended up using NBA or baseball data just because it was easier to get than the NBA data. But all the sports out there use next gen metrics and analytics. So that's about it for me. If anyone has any questions or comments, feel free to speak up. All right, doesn't look like there's any questions from the YouTube chat, and looks like there's no questions from the Zoom chat. We'll go ahead and wrap up for today. Thank you everyone here for joining us for Cassandra Lunch number 99. Don't forget, next week is our big 100. So don't forget to like, subscribe, and turn on the notification bell so you don't miss the Cassandra Lunch number 100 live. I'm not sure what Rahul's got planned, but hopefully it'll be a good talk. And with that, we'll wrap it up and we'll see you guys same place, same time next week. Take care.